Welcome everyone. This is the December Beginners Workshop for DataSHIELD. I'm the presenter for the first half, Alex Westerberg, and my colleague Demetris Avraam will be presenting some things in the second half. Many thanks to UCAN Connect for helping put this together and gather all of the people who might want it to give them the opportunity to have a go for the first time. So the first slide we were on, that is in case you haven't yet done the download. I would advise it only if you have quite fast internet because it's quite a long download to do, but it does give you the chance to catch up. I'll come back to this at the end. So this is the structure. It's a 2-hour workshop, longer than last time in the summer, because this time we have added a practical element. So we are hoping that by downloading the virtual machine and then running it, you will have the tools to be able to run DataSHIELD code at the same time as what we are showing you, and also to make small changes and experiment to gain an even deeper understanding. So that was all in the invitation link. You were directed to download Virtualbox, the virtual machine image, which is quite a large download, as I said. And we will be showing you how to put all of that together and how to set it up in the first section of the tutorial. After that, we'll be doing 15-minute chunks of different types of statistical code and explaining it and giving chances for questions. So, what is DataSHIELD? Well, I always find that the definition of a privacy-preserving federated analysis software is the most helpful one for me, because it contains those two most important parts of the definition. So privacy preserving, this entails when functions are sent from the analyst's computer to the data server, the data server will run DataSHIELD code on the data there, but built into those commands are disclosure checks. So it's been coded to understand if any kind of request will accidentally or on purpose cause disclosure. So say you did the mean of a vector that's one item long, then that would be returning the actual very revealing result. So that, in that case, it would go the disclosive route, and an error message would be returned to the analyst and no results. So all of these functions have been very carefully created so that there's absolutely nothing you can do and no inferences that can be made that would be disclosive. The second part is that it's a federated analysis. So the data servers, they can remain where the data was collected or at the data custodian's location. They don't have to be physically transported to the analyst or to a central warehouse. There is no chance for interception of the physical memory stick, and there's none of the inefficiencies involved. So this is another reason for efficiency. Going back to what it is, so it's a way of analyzing sensitive data at an individual level without providing direct access. But we also have to keep in mind what it isn't. There isn't a data harmonization aspect. The data harmonization would have to happen before data goes live on the servers. It's also not yet a graphical user interface analysis tool. So you do have to understand the R language, and you have to get accustomed to the R functions. But that is what this workshop is all about. It's getting you accustomed to it and letting you have a practice. So this is an animation of what a DataSHIELD analysis looks like and shows you the moving parts. So that's us. In my case, I'm in the UK. The analyst will know about particular data servers with data that they want to analyze. So that's me. And I have been given the login details by the people on the data server who trust me to log in and do a DataSHIELD analysis on them. They get sent, verifying that I'm someone who is allowed to log in. And then an R environment is established on the data server. And that connection between these two elements is the DataSHIELD session. Now there's a login script with information about which particular data to connect to and password, etc. And that is passed from our R session to the data server's R session. And other things that could have been sent in that script are analysis code, and then this on the R server runs as those cogs are showing, and results are generated. So the results after the disclosure check get sent back to the analyst's session, but also the command will have gone out to all of the other data servers, and this is the federated aspect, happening all the different servers at once, and they get brought back. And then the results get combined, so you can have meta-analysis results. Oh, I didn't know that was the last slide, last animation. So that's basically showing you where, when you're sending DataSHIELD commands, that's where it goes out to the various servers and how it comes back. So what are those commands that we can send out? Well, I just did some last minute checks, and there are 98 functions released within the DataSHIELD client-side packages, and we'll be going through quite a few of them in the coming demonstration. That's the full list. This PowerPoint will be available to download at the end, so you can click on that link if you are curious about where to find those 98 functions. So this demonstration, it is meant to be a live demonstration, so we've set up a few things to make that easier for you. The Virtualbox that we linked you to in the email invite and the virtual machine image, hopefully as many as possible of you will have downloaded it. There is a live poll going on to see how many of you actually managed to do that. If you haven't, that's all right. It will also be beneficial for you watching because we will be explaining all the code, we'll be running the code, you'll see the results of the code. But for those of you who have managed to, hopefully it will just add something to the experience, and it will be a script that you can go away after the session and keep experimenting with, and hopefully get you accustomed to how to do things. The R and RStudio we ask you to download is a backup in case our virtual machine has too many problems. I'm going to show you how to set up Virtualbox and the virtual machine image. So just to be clear, a virtual machine, which you may find me abbreviating to VM quite often because we say it a lot. So it's like a small computer that virtually operates inside your computer. So it's using processor, memory, and all of that, but it is acting as a separate entity. And in this case, it's acting as the data server, but also acting as the analysis server. You'll see how that works in a second. So after we've done the setup, I will be accessing RStudio on a web browser. So that's RStudio server. And you will be able to do that too if you've got the virtual machine successfully running. If you're familiar with R, but not with RStudio Notebook, that is what I'm using. It's just a different kind of environment within RStudio. If you want, you can just use a normal script if that's more familiar to you. We're going to then log into the data and show how to conduct statistical analyses using DataSHIELD functions. So this setup phase is over on a little bit, I think, but I'm sure we'll get back up to speed soon. So for each topic, which went out in the intro email, say summary statistic functions might be one of the topics, then we'll spend about 5 minutes showing you what different example code, and then maybe 5 minutes to have a go on your own sessions, and 5 minutes answering questions on the topic. Some of the topics that might not be quite possible, some things might take longer, but we're taking this in a flexible approach, so we'll see how the questions go for each. Yes, so I think I've seen the chat button flashing a little bit already. We will be picking up your questions as we go. Stuart is the technical support on this, so he'll be monitoring in case you're saying, I can't get my VM booting the way you showed, and we'll be providing the kind of support that is possible under the time constraints. And we'll be flagging me up if something's going wrong for a lot of different people. And the statistics or how does this work kind of questions, Dimitri will be monitoring the chat while I'm presenting for that kind of thing. And we will answer some of the questions during the short breaks, but some more difficult or longer answers will be answered at the end. So there we go. Here's an animation of a cat that I found. We'll get started. Elaine, have you got the poll results of that? We have about 15 people saying they have, so that's a good number already. So hopefully you'll be able to follow my next setup steps. As I said to the people who didn't manage to set up the software, yeah, it will still be beneficial to be watching for the statistical code. Right, let's exit the PowerPoint. So first thing first is you will have a Virtualbox installation setup. So I think that will be there you go. So it's exe. So if you can navigate to wherever in your file system you downloaded it and then run it. I already have an instance set up, but I'll just go through the installer just to let you know what it looks like. So because I've already got it set up, there's these options which you won't see. You'll just have to click through the install settings to get it set up. I'll not do this. I don't want to mess it up. But I'll give just a minute or two while you all manage to do that. And in the meantime, I've got the main Virtualbox home screen, which you will see when you first launch it. What will happen after you've managed to set it up is you'll have to import a virtual machine image. So that's the file with all the instructions of how this virtual computer is going to run. And To do this, you'll do File, then Import Appliance. And then again, you'll have to navigate to your file system where you did the download. In my case, I've got it inside Documents. So just to be clear, it's this open virtualization format file type that you're searching for. And then once you have selected it, you can go Next. And then all of this will be correct if you've downloaded the right Virtualbox, which you should have done. And then you can press Import. Again, I'm not going to do that because I've already got mine ready to go, but that import stage will take maybe 1 or 2 minutes, depending on your computer's power.
Alex, I have a question here. Do they need to have admin rights in the laptop to install the VirtualBox?
It is possible that they do. Stuart, would you say that they do have to?
Yes, I think you do need admin rights.
Yes.
Yeah, okay. Okay.
Once you have your imported virtual machine, you'll just need to quickly configure it to make sure it works correctly. The first thing to go is into Settings. Now you can get to that with this orange cog up here or right-clicking on it and Settings. And then we'll go into the network. And you don't have to change anything, but we're making sure that adapter 1 is attached to NAT, and adapter 2 is host only adapter. Again, we're not changing anything, but it makes sure that the virtual machine is set up correctly. The second thing, once you've done that, you go to this tools bar at the top and right-click on Host Network Manager, and you'll get a new window pop up. So if there is nothing here, you will need to click Create, and it's called VirtualBox Host Only Ethernet Adapter. And then you need DHCP server, that box to be unchecked, so not enabled. And then while selected, you can see this adapter section and just check that this IPv4 and network mask is correct. So the IPv4 address is 192.168.56.1. The network mask is 255.255.255.0. And then hopefully, if you've changed anything, click Apply, but I haven't, so I'm just going to click Close. If you are struggling to remember all of this, this recording is going to go on our website afterwards. You can play and pause it at the right speed for you. It's also shown in the instructions in our DataSHIELD installation hub. And it's also customized for which operating system you are using. So don't worry if you're not fully keeping up, but if you have managed to, that's great. So the next part is to run the virtual machine. So here I'm going to click on the virtual machine, which I think will be called 2020-1202. I've called it master, but here I'm going to click start. You can also right click and start. And because this is a whole machine within a machine booting, it is going to take 1 or 2 minutes to do. In the meantime, while this is booting, I'm just going to paste this in the chat, this website, which is the hub for what the beginner workshop today is all about. Because from here, we're going to access the actual virtual machine information page. There you go, that's posted to everyone. So going on there would bring you to this page. And we'll scroll halfway down to this workshop VM special just below the workshop contents subheading. And I'll open that in a new tab. So as I said in the setup, we're going to try and lead you through this on an RStudio server. And that is hosted like a website on the virtual machine we've just launched. So if we can click on it, that means that the virtual machine has booted. Just seeing the question from Amanda, yes, you will be able to go through all of this after the workshop, correct? So I'm going to log in with the username Vagrant and the password the same, Vagrant again. And click sign in. Chrome is not going to be happy that this is a not very secure password, but it doesn't matter because it's not really on the internet. So this here is the RStudio notebook.
Alex?
Yes.
Can we show again the slide with how you configure the host network manager?
Certainly, yeah. So firstly, I assume this is a question for after having imported the right virtual machine image. So firstly, you go to settings. So it's this orange cog in the top right side of the screen, or you just right click on it and go settings. And that's where you go to network and check adapter 1 is NAT and check adapter 2 is host only adapter, but you don't change those. You just click OK. The second part was host network settings, which is this top bar here, tools bar. When you select it, it should go blue, and then right click it and go down to host network manager. That's how you get to it. And then you're basically checking that it's set up correctly in terms of the adapter IP addresses and a DHCP server is not enabled. Has that covered your question?
I guess, yes. Yeah.
Cool. Just bear with us. This is quite new for us too. It's very difficult to try and get people running stuff on their machines when we can't walk up and have a look at the same screen as you. But hopefully once it's all set up, then we'll all be in the same place with regards to having this RStudio notebook to run through. So I'll just begin explaining. So in case you've only ever used RStudio, well, RScript before, this is more for presentation purposes. So in between the R code in these gray sections is explanation text, and it's using the markdown style. So in case you wanted to use it. So I think I've waited long enough for this virtual machine to fully boot. So we have got this login box here. We don't need that. But what we can do is from the workshop VM special, we can go to the Opal. So Opal is a system which manages the data and we also use it in the login script. So by clicking on that link and then getting here to username and password, this portal login, that shows that the virtual machine has been running long enough where we are ready to log into the data and run some commands on it. Oh yeah, RStudio server. So I'm just going to start running the code chunks. For the people who are following and doing it themselves live, hopefully if it's taking you just a little bit longer, you'll get to this stage and be able to run these code chunks to see yourself how it's going. But I'm going to proceed now for the benefit of the people who are just watching. So this R session has been set up beforehand to have all sorts of different useful packages set up already. So the three things that are needed for DataSHIELD to properly run are these different packages: DSI, DSOPL, and DSSpace Client. So this session info command, that'll check for you whether it's already there. So if we go to the D section, see we've got DSI, DSOPL happen to already be installed, but not DSSpace Client. So we're going to install the packages. This is here in case you're doing it for the first time. So this goes away to the CRAN and gets the various packages onto your session. We're not going to restart R prior to the installation. That's just not needed, and it would slow us down. So I've clicked no to all of them. Another thing to note about this RStudio server, you can still see the console, you just have to click this button in the bottom. That's going away and downloading. Just slowing down again to check, have we got any technical problems?
One thing is, if you're going to access the RStudio, you need to have it at being port 8787.
Yeah, this URL here. Just to, in case you're having trouble getting to that page, you can go to the DataSHIELD home page. So that's datashield.ac.uk. And then from that home page, you can click on the wiki. And from this wiki homepage, you can scroll down to Learn. And then below Learn, there is the DataSHIELD Beginners Workshop, December 2020. I've made that bold for today. And then from this Beginners Workshop page, you've got this link to the Workshop VM special. So that's under the Workshop Contents subheading. And this VM page has all the information about the IP address to click on and get to this RStudio server, as well as to the OPL login. So I'll close those again. Right, it looks like that should have downloaded successfully. Now, as with all our packages, we're going to library them to make sure they're actually running in our session. And how to check they're actually successfully libraried? Well, we're going to use the session info devtools command again. And if we scroll on this screen, yeah, so there's DSSpace Client, there's DSI, and there's DS.
Alex, could you paste in the URL into the chat, please?
Oh, yes. So the URL for the VM page, if I can just get the chat, and the link I've pasted is to this one you're seeing on my screen, which has the various links on it. So we've now got to the stage where you are actually ready to learn some DataSHIELD. So hopefully the setup stage that's got to this point will be useful in case you're trying to do it yourself. Of course, either right now or if you're trying to do it after this workshop. So, as in that animated diagram, we are using a login script which has the passwords, the IP addresses, the name of the data frames that we're trying to analyze. So we're using this builder command to create a data frame locally that will be sent off to the server. So we're going to, just to highlight that this run current chunk is how it works in the RStudio notebook. So we've created this login data from the builder, and we can see that's confirmed in the console. And then we do get an error message, but that's because we're using a non-secured connection because it's just a virtual machine on our own computer. The actual production version would use a secure connection. And then to actually connect, we use the DSI datashield.login command. And then one of the arguments inside this is login data. That's what we just created up here. So we press play on that. Well, press run on that. And we're logging into the different servers that have been set up for this virtual machine. So we have these useful progress bars which tell you how fast it's going. And then it's telling us we've assigned all the tables. And then this is the final output print. So that seems to have worked successfully. There would have been an error message if something was wrong. For the purposes of this demonstration, we're going to call the different studies University Medical Center Groningen, which is where UCAN Connect is based. We're going to call the second one Imperial College London, which I believe is where Athlete is based. And the third one we're going to call Newcastle University, which is where we are based, the core DataSHIELD team. And that's just so you can picture in your head that the commands in real life would be going out to all sorts of far distant locations where the data is stored. So now that we've logged in, it would be the time to actually start exploring the data using commands. Just pausing quickly in case anything else needs to be explained. It would be useful, again, if we could have the participants who are actually doing this live would put their hands up that they have managed to run through all of the setup stage. And they are ready to actually do the commands. The benefit of having done it this way with the RStudio script already loaded on the virtual machine is that you have the code there in front of you ready to run. For those of you who are actually ready and are just waiting, one of the interesting things about RStudio Notebook is that not only do you get this R Markdown script, but you also get this HTML generated. So if you left click on that and then view in the web browser, you get a printout of all of the results of your analyses. So code chunks and the explanation alongside it. So you can just click on this and it will be a more visually appealing way of looking at the R code that we're running. So we got to the starting analysis stage. All right, so I think that's been enough time. So we're now actually logged into some data which is hosted on the virtual machine server. So we would want to explore the metadata of this data we've logged into. It's actually called CNSIM. That was actually specified in the table, well, in the login data frame. And CNSIM is some simulated health data. So because it's simulated, we can use it for training purposes. It doesn't actually matter if it gets disclosed, but all the techniques we're going to be using aren't actually going to allow disclosure. It's so we're going to go to the Opal portal. So again, if you've got to this workshop VM page, it can be accessed through the Opal 305 thing here. So you go onto here and you get the login page, and you need to use the standard account. So that's user and password. And click sign in. Again, Chrome isn't very happy, but that's okay for now because it's all on the local system. So here you've got the dashboard for the Opal. You can click on Explore Data, and then we can click on the data set we are studying today, which is CNSIM. And you get a little bit of metadata here. So the number of tables, the total number of variables, but that's actually 11 for each of the three, so that's come to 33. This section here down the left-hand side is the tables tab, and you can look in each of these is a table at a different location, or at least it would be in the real deployment. So if you click into CNSIM1, so that's the first CNSIM table, you get the dictionary, which is really important because each of the column names as it's stored have these abbreviated capitalized names. That's quite hard to understand what you're actually running the mean on, like the mean of lab TSC. What on earth is that? Well, it's actually the mean of total serum cholesterol. So I'm not exactly medically trained, but I've heard of these things in a medical context before. So if you were a medical researcher, you would be logging into a data frames, which hopefully you will understand what the variables are talking about, and you will have ideas for how to analyze them. Back to the RStudio server. So what about if we're querying using DataSHIELD commands? Well, there is a whole list of which DataSHIELD commands are available at our wiki page, where it's been split into different types. So I'm going to post this in the chat, how to get to the list of all the functions. And I'm going to go there myself. So here you can see there are all sorts of functions like data structure queries, summary statistics, matrices, tables. There's a newly developed survival analysis, if that was the kind of research you were wanting to do. Distribution generating functions, all sorts of use cases for that. Modeling functions for linear models, generalized linear models, whether that's logistic link or log link or identity link. And plotting functions. That's only some of them. There's also these assign type data preparation functions, but they're more often used for developers. Maybe that's not the case, Dimitri. Analysts might also want to create like data frames or stuff. Is that true?
Do you mean from the client side?
Yeah, from the client side.
You can do whatever you want on the client side, but it's not possible to send an object, any object from the client to the server. But you can have a combination of analysis. For example, you can let's say get the regression outcomes from the servers when you feed a model. And then when you have this outcome on your client, you can do whatever you want there using any native R function.
Yeah. So it might be useful for the rest of this demonstration to just keep this window open in your browser, and it allows you to keep an eye on what kind of functions you can do to the data. Obviously, we're going to be showing you a few, but in case you wanted to branch out, if you had your own ideas about types of analyses you wanted to do, especially after this demo is over, this is the one to use. This is the up-to-date list of everything that's currently released. So back to the script. Two commands we can use to explore the metadata. So there's dsdim. So DataSHIELD functions are prefixed by ds dot. That lets you know it's a DataSHIELD client-side function that will only work in a DataSHIELD environment. So will only work once you've done that login script up here. So dsdim, and we have to have an object that we're running the command on. And in the login script, we said that the data on the servers is going to be called D. Another thing very important to note is objects that are sent for the server side to interpret must be encased in these quotation marks. That's to do with commands being sent through as a string. So if it wasn't in quotation marks, it could get lost and the syntax wouldn't be right. The final thing to note is for every DataSHIELD command, it's good practice to name the data source you're connecting to. Connections was set as a local object up here. And it allows you to say connections without any bracket at the end means you're connecting to all three data sets that we've connected to. But if you did one at the end like this, that would allow you to only connect to the first one and not have it send to the other two. But it's good to have that there for clarity and so you know where your commands are going to. So we're going to run dsdim. So very often DataSHIELD commands are very similar to the standard R equivalent. So dim the dimension, as I think it is in regular R. And we're also going to do the column names of this D object. So clicking run will run both of these at once, and then you get the printout of the results. So here we're seeing the dimensions. So dimensions of the first study at Groningen, dimensions of the second study in Imperial, and dimensions of the third study in Newcastle. So slightly different amounts of rows in each place, but 11 columns in all of them. And this is the combined totals, as it says. Ooh. And then the second command we run, column names. So that is the column names for each of the three studies. And we can see that they're all the same. And as I said before, if you want to know what these codes are, you can see the information about them at the Opal here, at the Opal portal. So for this analysis session, we'll investigate lab HDL. Just quickly check what lab HDL is. It's HDL cholesterol. So some things to learn about this. What's its class as defined in R? What's its length and what's its mean? In all three situations, I'm specifying D $lab HDL, so that's looking at the data frame D and then using dollar notation to look at a particular column of that data frame and then calling by the name of the column. Run all three of these at once. So its class on each of the three servers is a numeric. That's very good. If it was different on one of them, that would be quite a problem. Its length. This is quite similar to DIM, but we're again learning that it's 2,163 rows on the first server and 3,088 on the second server, 4,128 on the third server. And then this section is the mean on this particular variable. So the mean on each of the three servers, so we've got 1.569, 1.557, 1.575, rounded to 3 decimal places each. So pretty similar, but there are slight differences. Another thing is it's telling you how many NAs, well, missing values have been removed. So obviously in data it might not be perfectly cleaned, and this function will remove the missing so the function doesn't go wrong. This final section of the output, the validity message, that is just telling us that the mean has successfully calculated and there's been no DataSHIELD errors like disclosure errors that might have cropped up if we were running on too few data. So if we go back to the list of all functions and we go down to the summary statistics functions, ds mean we've just run, but there's also this ds quantile mean. And say we're new to DataSHIELD, we don't know what that actually does. There are built-in help functions for us to learn what things do. So just as in regular R, you'd put a question mark before the function name and then run it. So this brings up the help page in this window of RStudio, and it'll show you the different arguments and the default arguments. It'll tell you some more information about the arguments, and then I think in most cases of DataSHIELD functions there is an example that you could run in your R script. So what we're seeing here is that it will calculate the mean and the quantile values. Okay, that could be interesting if you wanted to know the quantiles of this particular HDL cholesterol on different servers. So we're going to first run this top row. I'm doing that for those of you who are following along by putting my cursor on that particular line and doing Control and Enter keys on my keyboard. So we're seeing that we've got the 5th percentile, the 10th percentile, the 25th, 50th, all the way to the 95th percentile. Obviously, it would be bad to show the very bottom, like the 0th percentile or the 100th, because that is an actual data point, and that would be disclosive, and therefore DataSHIELD commands do not allow us to see that. The mean is also sent back to us. But what is this argument here? Type equals combine. That's a setting where we can either combine all of the 3 data servers results together, or we can present them as split by data server. So how about we do it type equals split. I'm going to do Control and Enter again. And here we can see the percentiles for firstly Groningen, then Imperial College London, and then Newcastle. So you can see that the median, the 50th percentile, does actually vary as well as the mean. So 1.58, 1.56, 1.59. So if you're wondering, if you have a DataSHIELD function and you're wondering if it can be customized, yes, use the function's help to see what its arguments can do. Now, maybe we wanted to know the variance, so we're going to run the help for the variance to check what its arguments are. So as normal, we've got the data object to investigate. We can split or combine it. We can run checks, which is a new thing. So checks of model components. I don't think we need to do that today. So I'm going to stay with the default, which is false. And as ever, specify the data sources. So here we've written it out. We've got the specific data frame and column we're talking about. We're splitting it and we're referencing the data source, which is connections. And here we can see that the variance again differs very slightly by the different study we're connected to. Again, a validity message. So say you've got the variance, you've gone on to a study and you've worked out what the variance is, and you now want to store that on your local R session. Well, that's actually possible. Each of these things that is sent back from the server, it is stored as a list, and then you can assign that list and you can assign different parts of that list. So firstly, we're going to assign to object A in the local environment the particular first part of the DSVAR output. We're using this double square brackets because the output is a list. It wouldn't work, for example, if you did single square brackets. So we're going to bring out A, and we have object A printed, but that's still quite a complicated table. It's not a number that we could run calculations on. So we need to look inside this table, and we want to look for the first part of the data frame in that output list. And we do that by another double set of square brackets, and then reference it first row, first column, like you would access a data frame. We've assigned that to B and then printed B, and we can see that 0.1707959, yeah, that corresponds with the output we got. So yeah, square brackets because we're accessing an element of a list. Just going to push on to the end of my section. Dimitri will take over from tables. So, assign type functions. You've noticed so far that commands that we've run in DataSHIELD have brought back results. And in DataSHIELD, we call that aggregate type functions. But there are certain situations where a calculation needs to be run, but bringing it back would cause disclosure issues. So to illustrate this, I have demonstrated with dslog. So dslog, that's the DataSHIELD equivalent of regular R's logarithm function. So firstly, we're going to list what objects are on the DataSHIELD, are on the servers. Wait for the printout. So, and each of them we're seeing there's these objects on, firstly on Groningen, then on Imperial, then on Newcastle. So R, global environment, and D. Then we run DSLog on HDL cholesterol. Here we are assigning a new object. So we're going to call it HDL cholesterol underscore log. And then we're going to list again what objects are on the server. So after doing that, we can see that a new object has created successfully. Why can we not see the, why can we not see what HDL log actually is? Well, the logged values of a column are easily reversible. So if you did reverse log, I put to an exponent of the printed results, then you could get back to the raw data, and then you'd be looking at disclosive individual level patient data, and that's exactly what we are aiming to prevent at DataSHIELD. So for functions like these, you can only assign it to a server-side object and then run further commands on it from there. So the next thing we've done on it is what is the mean of this new logged HDL cholesterol object. So we'll scroll down and see that the new mean is 0.409 and valid analysis. And this compares with the original mean of 1.56. So yes, DSLog has successfully changed, has successfully run on that column and noticeably changed the mean of the new object. There is a new assign type function to DataSHIELD 6.1, which is the newest release, which is square root, which is very useful to have. So square root of HDL cholesterol again, because that's what we're investigating. And we're going to create a new object of it, lab HDL underscore square root. And again, we're just going to check, we're using DSLS for list and DSMean, that the new object is successfully created. Waiting for the printout. So yes, the LS has noted that there is another new object, lab HDL square root. The mean after and before. So after it's 1.24 and before it was 1.56. So that sounds to me pretty correct that it has taken square root values. DSMake is another one for you to investigate. It does things like if you wanted to add the number 1 to HDL cholesterol. So if you run the help for that, so that the toAssign argument will specify the arithmetic expression. The new object is necessary because you'll be creating a new object containing the results of the calculation, and as always, specify data sources. You can do this in your own time, as well as investigate any and all other DataSHIELD commands that we have here on the list of functions. Dimitri, would you like me to show people how to upload a script which contains the modeling functions that you're going to be showing off?
Are not included in your script?
They are here in my script, but in case people wanted to follow along. So just for context, there's some very slight differences between the script uploaded to the virtual machine RStudio server and what we're demonstrating today, but you will be able to see it afterwards.
Yeah, I don't mind.
Okay, so just quickly, from this this workshop page that we showed you nearer the beginning, if you scroll down to the R Markdown script, this is also under workshop contents. You can, there's a Google Drive download link. This is a really small file, so very easy to do. And so that goes into our downloads folder, in my case. And on RStudio server, just like regular RStudio, there's this files area in the same boxes where help is. And you can upload this orange upload button here. And that allows you to navigate, choose file, allows you to select the notebook that you've just downloaded, open, and then OK. And that uploads straight to the RStudio server file location. And then by clicking on that, it will open the code that we're about to show you. So I think that should be sufficient, and you can get going with tables, Dimitri.
If we follow the final notebook that you downloaded, we can go up to the section of the tables, down.
I think it's just above that.
Yeah, okay. Okay, so another function in DataSHIELD, which is an aggregate function, is DSTable. This function allows you to create contingency tables, either one-dimensional, two-dimensional, or three-dimensional. So if you input as an argument one variable, and in that case, for table functions, we use categorical variables just to list how many observations we have in each category. If the input variables that you add in this function is just one categorical variable, you can get out the table or showing the observations of gender, how many females and how many males we have in each study. Also, this function returns some other information. Instead of returning only the number of observations, which is the bottom table, it returns also the proportion column-wise and row-wise. So you can see here that in study 1, we have 192 males and 171 females. So in that case, you need also to remember how you define the categories in your study. And one thing that you can see how the categories are defined, you can go back to the, so here, when you upload when the data owner uploads the data in Opal and use and detail data dictionary, there are some columns here. For example, when we have the gender variable, we can see that it's a binary variable including two categories, but the data owner can add more columns here, including details where he can specify what 0 means and what the 1 means, to just know what is the female and what represent males. Okay, let's go back. So this is a one-dimensional table, and we have the observations per category in this categorical variable per study. Now we can do a similar thing for two categorical variables. So for example, here we want to see how many individuals have diabetes and how many of those are males and how many of those are females. So if we run the first row here, okay, so this is the help file. If we see the outcome of the first row, you can see that in this study, in the first study, we have 0 individual. Okay, here. So in the first study, we have 171 males without diabetes, 21 males with diabetes, then 162 females with no diabetes, and 9 females with diabetes. So this is a two-dimensional contingency table. In some cases, you can add also a third variable, and you can create a three-dimensional table. One thing why we show this function here is to show you an example when there is a potential disclosure. The function in DataSHIELD doesn't return the table in that case and return a state message. So for example, here in the second row, we want to have a look on how many individuals had a heart attack and compare these numbers by gender. So if you run this row here now, and see the results, you can see that the table didn't create it from any study, and we got an error message. And the reason is that in any of the cells in a two-dimensional table, we have less count than a specified threshold. In that case, this threshold is 3, which means that if we have one cell in a table which is less than 3, the table doesn't create it in DataSHIELD. And this is one disclosure filter that we have. And all those disclosure filters can be controlled by the data custodian. If you go back to the Opal web interface under administration, okay.
It may be that because this is a user account only.
Okay. Okay, yeah, okay. So there are a list of disclosure controls, and these are specified by the data owner. Okay, so if you, for example, if you analyze rare diseases and you want to change these filters, for example, you can minimize this value to 1. In that case, the data owner can do that through the Opal web interface, but under agreement in the whole consortium. So these are the default options, but the data owners are possible to change those. So let's go. The next part of this demonstration is about graphs. The first graph that we are going to demonstrate is the Nds histogram. It's similar to the histogram function in native R. And again, here we are going to demonstrate the histogram of cholesterol. And if we run this function, you can see in the output a message saying that for the Imperial College server, we have 1 invalid cell. And for the Newcastle server, we have 0 invalid cells. What does this mean? It means that on the way that we protect potential disclosure for a histogram, we have the bars that represent the frequency of observations in each subinterval of the range of the variable. But if we have bars with few observations, we remove those from the histograms. So this message here says that the histogram coming from the Newcastle University server, it's exactly the same as the histogram as you will get if you run the analysis in normal R, if you have access to the data and run the analysis in normal R. But for the Imperial College histogram, 1 bar was deleted from the histogram. So this is the way that we control disclosure in this graph. The next graph that we are going to show is the box plot. This is a newly developed graph. Xavier from IS Global contributed to the latest development of that. And because this function at the current version uses an R package called ggplot2, which allows to make stylistic changes in your graphics, we are going to install this in our session here, just to show you how you can do whatever you want on the client side, on the analysis computer, if you get an object from each server. So if you want to install a package in R, you just follow, you just use this command, install.packages, and inside code marks, you put the name of the package. And then after you install the package, you need to load it using the command library. So Alex, how can I select few rows from this chunk?
I can do it for you. You have to press Control and Enter on your keyboard, but I'm not sure if your keyboard will be.
Yeah. Anyway, I can run the whole chunk.
Yeah.
When we load the package, we can use the dsboxplot function from DataSHIELD. And in that case, again, we can use from the data frame D, which variable we want to create the box plot. In that case, it's a numeric variable, a continuous variable. But also, we can group this variable by a categorical variable. So if we run this command here, we are going to see a box plot of the cholesterol across the two categories of gender. And in that case, by default, the outcome of this function is the pooled box plot. So it's the combined box plot from the three studies. You can also use the argument type equal to split to have one box plot per study. So let's run the whole chunk here. As you can see, the help file, you can see here the type, which is by default the pooled, but you can also change this to split to see a single box plot per study. So it's quite slow because it does the installation, I guess, of the package. Yeah, if you click in your console, you can see where the process is. Okay, and if we go up to the notebook, you can see here the output of this function. So we have the cholesterol level between males and females. Two other graphical functions that we have in DataSHIELD is the heat map plot and contour plot. These are similar to scatter plots, but they have an additional third dimension. We are not going to show in this demonstration, but you can click on this chunk and see the help file on how you can use those two. So let's see how we protect privacy in scatter plots. So if you want to create a scatter plot, this function is similar to the plot function in R, where you have two input variables, X and Y, and usually these two variables are continuous. You can have also a categorical variable or two, but usually the scatter plot represents the relationship between two continuous variables. So let's plot the scatter plot between cholesterol and BMI. So as you can see here, we have the scatter plot from each study. In the same way as we did for box plot, you can add the argument type equal to combined and create the scatter plot across the three studies in one figure. So here, because by definition, the scatter plot is disclosive, if you don't have any production controls and you get the scatter plot from real data, the coordinates of each individual value here, individual point in the plot, represent the actual values of the two variables that we have as inputs. So in order to protect this potential disclosure, we have two anonymization techniques, especially for the graphical functions, and we obscure the real values with two anonymization techniques. The first one is the probabilistic anonymization. Basically, in that case, from the real data points, we add in each real data point a small random noise. And we have also the deterministic anonymization, where we apply an algorithm where for each data point, we search the nearest neighbors and we replace the coordinates of each real point with the centroid of those nearest neighbors. So this is something different in DataSHIELD because here we display something which is not based on real data. All the other functions in DataSHIELD are doing analysis in the real data, except the graphical functions, which display some anonymized values, but we created these algorithms in order to minimize the risk of disclosure, but also to keep the utility of the graphs. So if you have a relationship across two variables, when you display this relationship in the anonymized values, you will be able to see the actual relationship from the real data. So this is something important. If you are writing a paper, for example, and you want to display a figure coming from DataSHIELD, you can have a note that the points here on this graph are not the actual values, but are anonymized values through a specific technique. So this is about graphs. And then I think one new feature that we added in the scatter plots is that the analyst can get back those anonymized values in the console. So you can add this argument in your function, return coords, which mainly returns coordinates equal to true. By default, this is set to false. But if you set this to true, you can get in your console the coordinates, the X and Y coordinate of the anonymized values. So if you run this and get the coordinates, so you need to assign the outcome of this function with a specific name. Here we just use the name coords. Then we can use this outcome and do whatever we want in R, in native R. So as you can see, I'm going to get these coordinates and use the ggplot to make better visualizations. So let's run the whole chunk here. And if we go back to the console and type coords, you can see that we get back from each study a list with two elements. The first element is a data frame with two columns, is the X and Y variable. And the second element in the list is a study site message. So in order to use the coordinates in another function in native R, we need just to extract from this list the data frame. So is what this line does. It takes the first, from the first study, the first element from the list, and also we convert the list to a data frame. So this is an example on how you can get an object from DataSHIELD and do whatever analysis you want in native R. And then we just we just use the ggplot. So as you can see here, we can have a better visualization than before. By default, we got this. But if you do what I show you now, you can use ggplot and do better visualization. So here you can change the labels, you can change the fonts, the colors, and you can put titles and so on. Okay, so this is the section about graphs. Maybe there are some questions. About the first question by Amanda, if DataSHIELD is compatible with tidyverse functions, in addition to ggplot, that's true on the client side, on the analysis computer. You can take the outcome, as I said you. For example, you can take a table from an analysis in DataSHIELD and convert this table to a table, for example, and use dplyr functions and do whatever you want. Now, at the moment, we are looking on how we can implement tidyverse packages on the servers to make basically to make the manipulation of data easier for the analyst. The next question, box plot is the first plot. Okay, this is by Stuart. Yeah, okay, so the question by Chuang about if DataSHIELD can bring data back to the user. This is the note that I tell you. Then DataSHIELD can only bring data, bring anonymized data through the graphical functions. So the actual data are never come back to the user, or the user cannot see the actual data. Okay, if you don't have any other questions about the graphics, we can move down to the last part of this presentation, which is, there is another question. I want to do a qualitative analysis on image data. There are some noise applying technique. Okay, so at the moment, we don't have functions allowing analysis of images. But I'm not sure if Agis is working in IS Global. In collaboration with a team in IS Global, we are working on how to implement packages in DataSHIELD to allow analysis of images. And one part of these packages, we want to allow anonymization of images. And one technique that we can use is the addition of random noise. By the way, if you have any specific type of data, we can speak later, because at the moment we are looking to implement packages from Neuroconductor in R, which does analysis of images of neuroimage data. But in some other settings, you might want to analyze, for example, lung scans on any other type of images. So we can see with the users what type of analysis they want to do in order to implement new functions. Okay. I'm not sure if there is any other question about graphs here. Okay, let's go to the final part of this presentation, which is about generalized linear models. Here I will show you simple things that you can do, but in DataSHIELD you can you can do complex regression analysis, including regression with mixed models, and also you can do survival analysis through piecewise exponential regression for the people that are familiar with that technique. And at the moment we are looking also to implement mediation analysis and survival analysis through Cox regression. So these are some specific techniques that you might need for your projects, and we can have a discussion later. So before we go to the specific commands here, in DataSHIELD at the moment, we allow two approaches to apply regression models. The first approach is called individual partition data approach. And in that case, if you have data across multiple sites and you can't pull those data in one central warehouse, but you want to analyze those data in a federated way, then DSGLM function in DataSHIELD does a virtual pooling of the data, which means that you get back results from regression. And these results are the same as you pull the data in a single warehouse and run a single model there. So we have some publications that you can see the mathematics behind this, how these two approaches are equivalent. But I will not say a lot of details here, just to say that this is the first approach. We virtually pull data and we get the results from the regression in the client by pulling all the studies together. The second approach is the study level meta-analysis. In that case, you feed a model in each server separately until completion. And then you get back the results, the final results from each server back to the analysis computer. And the analysis, the client-side function, does the meta-analysis. Is the same as the animation that Alex showed in the initial slides. So this is the meta-analysis. So in relation to what is better between these two approaches, it depends on the situation, and it's up to the analyst. In some cases, the IPND version adds statistical power, especially if you have some small data sets in the consortium. On the other hand, the study level meta-analysis is commonly used, especially when you have a heterogeneity between the different studies. So let's see a simple example here. We want to apply a simple linear regression to check if there is a relationship between triglycerides and BMI. And let's see the correlation between these two variables first. So similar to the R function core, we have the DS counterpart of this correlation function. And as you can see here, we get again a list of some elements. And one list is the correlation matrix. So on the diagonal of this matrix, we have the correlation between each variable by itself. So it's one. And in the non-diagonal elements, we have the correlation between BMI and the other continuous variable that we are using here. So as you can see, there is some correlation between these two. So the next part or the next chunk of this demonstration creates a scatter plot between these two variables, just to see if there is a relationship between those and if this relationship is linear or not. Because the correlation is not strong here, we don't have a good evidence, but we are going to apply a simple linear regression model to see how the function in DataSHIELD performs. So this is the first approach, the IPND. It's similar to the GLM function in R, which is the abbreviation of Generalized Linear Model. The first argument is the formula. So we need to put the outcome variable first, then the tilde symbol, which is similar to equal, to the equal symbol. And on the right-hand side of the formula, we put the sum of the explanatory variables that we have. So in that case, we are using only one explanatory variable. And then we need to specify the family. This is the distribution of the outcome variable. And because the outcome variable is a continuous variable, it follows a Gaussian distribution. We need to apply a linear model with a Gaussian distribution. So let's run this command, and you can see that we get a table with the regression outcomes. We have some other information before. And this is the main regression outcome. We have the estimate coefficients. We have the intercept because it's a linear model. And then we have the slope. And we have also standard errors and p-values just to compare to see if those terms are statistically significant or not. So the second approach is the SLMA. It's the same, we can use the same arguments, but in that case, the function is called ds.glm SLMA. And the difference here is that we can add the argument new obj equal to a name. And in that case, we save, we also get the regression outcomes back to the console, but we also save the outcomes to each server because we can use those later to get some other information. And the reason that we do that is because using regression, if you apply regression in native R, you can get back also residuals and the fitted values. In DataSHIELD, we blocked that return from the server to the client, because if you have the fitted values and the residuals, you can get the difference, and that's the actual values of the outcome variable. So in that case, you can save the regression outcomes at each server and use some other DataSHIELD function later to do some other analysis. So let's run the SLMA. And so as you can see here, we have the regression outcomes from each single study, because it's a study level meta-analysis approach. So the model was fit until completion in each study, and we get the coefficients and standard errors back. Yeah, this is the table from each study. And also at the bottom, you can see the pooled, the meta-analysis results, because the client-side function of SLMA gets the regression results from each server and meta-analyze those in R, in your client side, in your analysis computer. So this is the difference between GLM and GLM SLMA. Now, one reason that I told you that we save the outcome from a regression analysis in the servers is that because we can use the fitted values and plot the best fit, the best linear fit in that case, in the same graph as we have the scatter plot between the two numerical variables. So then GLM Predict is a new function. It's included in the latest release of DataSHIELD, and you add, as the first input, you put the object of the outcome that you saved from DSGLM SLMA. So this is an object including in your servers now. If you do in your console DSLS, it lists the objects from each server, and as you can see, the workshop.obj, it's included now in each server. So let's run these very quickly, and because we need to have some time for questions. And let's go below to the next chunk. Yeah, basically here, because the regression applies to complete cases, we need also to remove the missing values from the initial pair of the two variables, just to have the correct length of the two objects in the same plot. And as you can see, the next chunk that does the plot adds in the previous scatter plot the best linear fit. Okay, as you can see here, we have the initial data points, and this is the best linear fit that we got from SLMA. So this is the last point, but this example that I just showed you, it's a very simple example with a linear model, simple linear model with just one explanatory variable, but you can have more complex models. For example, you can have a logistic regression where the outcome here, it's a binary variable, and in that case, the family should be binomial. And also you can have interactions or you can add a lot of variables, including dummy variables and stuff like that. I think you can run those two chunks later and see the difference between the outcomes of IPND and SLMA versions. I think it's better if we, yeah, okay, the last part, it's a DSI function that you, when you finish your analysis, you need to log out from the connections. We have also some other function where you can save the workspace and come back later, but we can show you this in a next workshop. I think we can go to questions because we are quite late. Do you want to open a discussion, or can I follow questions from the chat? I want to distinguish this.
I think there were 3 questions that I noticed.
Yeah, so one question about what if one person is part of more studies, and I want to distinguish this. So initially, when you mean more studies, I think you mean that you want to have multiple connections. Maybe.
Yeah, I can explain maybe.
Yeah,
because yeah, just potentially that you have one person with some body mass index or some cholesterol index laboratory something, and he was taken 2 values, or like you have 2 values from the same person. If you speak about anonymization of the data, so I'm curious if the data are anonymized before the analysis or after, because if how you recognize that this value is from the one person, if you, and how does it work with this anonymization?
Okay, basically to avoid confusion, each analysis in DataSHIELD is done on the real data. We don't change any individual values. The anonymization, it takes place only when you want to visualize something. When you want to create a scatter plot, for example.
Okay, so yeah, the analysis is done before, and then the data are just sent without any identifiers or other possible.
But any other analysis is done on the real data, so you don't need to worry about anonymization here. For example, in your case, if you want to visualize a categorical variable, and you have let's say BMI with 2 categories, 0 and 1, the anonymization can take place again, but for example, if you add noise to the binary levels, what you will observe in the scatter plot are some continuous values. So maybe it's not a good example to display. Yeah,
because you were speaking about the anonymization, so I just wanted to know on which level it is, because I can have some analysis which maybe needs some kind of more specific information. So
yeah, basically all the analyses are done on the actual data. Okay. One thing that we didn't show in this demonstration is that we have a set of functions for data processing. So for example, if you have 2 studies, and in one study, as Alex said, the harmonization is a part that is done in a previous level before you use DataSHIELD. But let's say that after harmonization, you have 2 studies, and one study, BMI includes 2 categories, and in the second study, the BMI includes 3 categories. In that case, we have some functions where we allow user to make some processing. So for example, you can group 2 categories on the second study together, or do something else. But we didn't show this these functions here.
Okay, okay. Yes, thank you. Thank you for the answer. It's enough.
What is the next question?
There's a question from Sophia. If I want to perform a descriptive analysis, is there any function to perform it?
Yeah, basically in descriptive analysis, we have a set of functions about descriptive statistics, including the tables, the quantile means, different summary statistics, for example, mean, correlation, variance, covariance. What type of descriptive statistics do you want to apply?
Yes, I was talking about this exactly, like to know the percentage of different subjects, as you explained with DS dot table and all the things, but I don't know if there is some function to perform all of these together, like all the variables that I'm using in the moment.
Can I ask you in which project are you involved with?
I will start with life cycle.
Okay, yeah. Basically, I'm not sure if you know that Tim Catman developed Nds helper packaging lifecycle, where he basically combined many DataSHIELD functions together.
Okay.
And you can have a look there. What we are discussing with him is to put his developments in the base package in DataSHIELD. But everything is possible. I can send you a link of this package later if you want.
Perfect. Okay, thank you.
What you can do for descriptive statistics can be done in DataSHIELD at the moment.
Okay.
And I saw a question about PCA. I can't find the question now, but
Dimitri, I've got one further up the chat from Amanda saying, is DataSHIELD compatible with other tidyverse functions in addition to ggplot?
Yeah, I think we replied that before the modeling part. If Amanda has any other questions about that, we can discuss again.
I think, Dimitri, the question you were looking for is third from the bottom. Have you any plans for iteration-dependent analysis like PCA?
Yeah, okay, yeah, I found it. I'm not aware about TSNE and UMAP, but we have already, basically Xavier from IS Global already developed a first version of PCA. And we are at the stage where we're testing the function, and we are going to add this in a next release of DataSHIELD. But I'm not familiar with the other two techniques. I guess TS is for time series.
No, so TSNE and UMOB are quite similar to PCA. It's also a reduction of dimensions. But the important point here is that PCA has a long, or a high computing need. So TSNE and UMAP are much faster, and especially UMAP gives you additional information. So the problem is PCA is quite accurate in their information in the distance between clusters. And TSNE loses a lot of those information, and therefore UMAP came, which gained more information between these clusters. So it's like PCA takes too much time. TSNE was better, but not so correct with the dimensions. And UMAP is, I would say, the state of the art at the moment.
Okay, I will have a look. Basically, about iteration techniques in DataSHIELD, we are quite limited because we are careful on what information should be shared from one study to the other studies through the client. And for example, for PCA, the way that we are doing this now, we have a combined approach where we can estimate the pooled variance covariance matrix. And using this pooled variance covariance matrix, we can extract the principal components. But at the moment, we have developed an algorithm where using encryption decryption, you can send some information from one server to another without being able the client to get any actual data that can be identifying individual. And also the other studies that they get some information, they are not also able to get any individual level values from the server that it sends this information. So when we implement this algorithm, we are at the middle stage now. When we have this algorithm, we can make a lot of techniques in DataSHIELD, which we are restricted now, I think. But I will have a look on these two and check if we can do it also with the current version of DataSHIELD.
Great, thank you.
Yeah, we have Alex replied to the question.
Dimitri, possibly we could continue answering questions, but just before too many people disappear at 12:30 CET, just going to go over this final slide. So if you do have further questions that you come up with after this meeting, our forum is quick and easy to sign up to and free. You can get to our forum from our website, datashield.ac.uk. This demonstration has very closely mirrored what is on our beginner hub at our wiki, which is a 6-part training series in how to learn DataSHIELD. So if you do that, you will see lots of similar materials and similar commands and all the explanations that you can do at your own pace. There is some homework if you'd like to do that and learn DataSHIELD and how to use it. You can find that by going to the December workshop page, which has been posted in chat a couple of times. I'll post it in there again. You just have to scroll down to the bit called homework. And of course, if you want to learn more about us, there's our website, datashield.ac.uk, and our GitHub, which you can get to from the website. If you want to have any of the links that have been in this PowerPoint presentation, this PowerPoint presentation is also at that at the wiki page for this workshop. And I'm putting that in the chat now as Dimitri continues.
We have a question from Jose. Basically, we have a similar workshop for beginners during the athlete assembly in January. Yeah, can you open this link? Can we open the link with the events, because I think we have some events in December as well. Yeah, one thing that I want to comment about the whole demonstration is that if you are a user and you found the initial part about how to install VirtualBox and virtual machine quite difficult, this is not something that you are going to do in a real setting of analysis. What you are going to do is just create an R script and run your analysis there. The reason that we have this installation here, and because we don't have access to real data, we need to create these virtual machines having the fake data there, but we are looking to find better options to make this procedure faster. So if you found this part difficult, just to let you know that this is not included in a real analysis setting.
Yeah. And another thing to highlight is you may have seen a poll pop up. If you could fill in that to say how you found today's workshop, that would be really useful for us to optimize future workshops. Dimitri, did you want me to show the upcoming workshops?
Yeah, I think we have one about resources. Yeah, basically, I'm not sure the people that attended this workshop, if they are beginners or if they have used DataSHIELD before. If you have used DataSHIELD before, we have also the resources DataSHIELD in the 50. This is in January. Yeah, we don't have any other workshops in December. Okay, so we have also 3 other workshops in January. The first one is about the resources. It's a new feature of DataSHIELD on how you can get access to some data using URL and some other credentials. And this is, I will say that it's for more advanced users, but you are welcome to attend. On the 25th of January, it will be a workshop for beginners similar to today's one. If you have any suggestions for improvements, we are happy to make any changes. And also there is another one for resources on the 26th. That's the same as the one on the 15th of January. And then we have on the 27th, a specific workshop for omics analysis. That's a new package developed by a team in IS Global. And if you are interested to omics analysis, you can attend this also. Great. If you don't have any questions, we can say thank you for attending. And we are happy to answer more questions through the forum, the emails, or the next workshops. And we can keep in touch.
Thanks, everyone.
Thank you.